Good day to all of you. Today we shall solve a problem on natural join from relational algebra in DBMS. Let's start the session. The question we are going to take from BE examination. The problem statement is as follows. Write the relational algebraic expression to retrieve name and address of all the employees who work for accounts department. So to solve this problem, this example data we are taking in which we have employee table and department table, because we need employee name and address. So one table related employee details, and who work for accounts department means another table, that is department table, which keeps the details of all the departments. Okay. Then in employee table, based on department ID, if we take and if we go to department table, we can get to which department they work for. Okay. So step by step solution if you take, the first step is, so we have to select the accounts department details from department table. So this is the department table. Accounts department details means we'll have to choose those rows, means select those rows where department name is accounts. That is why we'll have to write the select operation related relational algebraic expression. So when we do select operation on department table, to choose only those rows in which department name is accounts, so that relational algebraic expression is written here. So department relation is taken as the input relation. Select operation is done, that this row indicates select operation. The condition specified is where department name is accounts. Then we'll get this output. So this output is stored in intermediate relation D. So that is what is D here. Okay. So for step 1, what output 1 is generated and saved in D table, if you verify, from department table there are 3 rows, 1, 2, 3. In only one row we have the accounts department name. So that is what we have got here, right? So this output relation can also be written as this. Here it is written in the form of set. Any table or relation is set of tuples, that is set of rows. Next, in the second step, this employee table is joined with D table. For that the relation expression is given here. So this is join operation symbol that we have already seen in previous video session. So this is employee relation joined with relation D. So this relation has to be joined with this relation. Okay. So in any join operation, if R and S are the two relations and this being the join operation, at the foot here we mention based on which column match it should be joined, that we mention. But here it is not mentioned. If it is not mentioned, then which columns are common for both? So department ID and department ID is column for both. So where department ID equal to department ID. So this condition will be here, that is department ID equal to department ID. So which column is common for both? Based on that column match, join operation will be done. Such join is called as natural join. Okay. So can you guess the output? You please pause the video and get join relation on your own. Please write it. So for that, please watch my previous video. Get to understand the concept. Then what will be the output of join operation? At this level or stage, or at this moment, one must be able to write. Okay. That is how we can learn any topic thoroughly. So what can be the output of this join operation? So join operation takes every row of first table and joins with every other row of second table. But this is natural join, means condition is department ID equal to department ID. So if you take first row in employee table, because employee table is mentioned here. Next, first row in second table, that is D table. Can we join both the rows? So for that, department ID, is it equal to department ID? So department ID is 10 here, department ID is also 10 here. That is why this row and this row must be joined, and that is written in the output relation, that is R. This is going to be our output relation R. Then how many columns here? 4 columns are here and 2 columns are here. But 4 plus 2, we will not have, only 5 columns, because this department ID and this department ID is same. Name is same. That is why it will be written only once. So 4 columns plus 1 column, they will be written in the output relation R. So that is the procedure with first row in the employee table. If you take second row in the employee table, can we join with the first row of D table? Here department ID is 20, here 10. So this cannot be joined. Then go to third row. Can we join? Here department ID is 10, here also 10. Hence it can be joined. So we have one more row where these values and this one value will be present. Okay. Then check with the fourth row. Can we join fourth row with this row? Here department ID is 30, here 10. We cannot join here. Then we have only 2 rows and 5 columns in the output relation R. That we shall write neatly next here. So here output 2, that is R table, out of this natural join operation, that relation is written here. Join output relation is written here. So it has 2 rows and 5 columns. Okay. Wherever department ID value matches, only those rows are present here. So these 4, wherever matching is found, the corresponding value from this D table we have. Okay. This output also can be written as set of tuples this way. So this join output relation R has all the details of employees belonging to accounts department. All the details means we have employee ID, name, address, department ID and department name. But in the question they have asked for only name and address. So out of this relation we'll have to project only these 2 columns. So in the third step we'll have to go for project operation on R, that is this table. So that is what is this third operation, in which we have project operation. So when we do project operation on R input relation and project only these 2 columns, that is name and address, we get the final result which are shown here. So result is the final output relation, in which we have name and address of the employees who belong to accounts department. So these 2 people belong to accounts department, because if you observe here, Alice and Charlie, department ID is 10. So 10 means it is accounts department. Okay. With that we come to the end of discussion. This was the given problem statement and this is the final answer. This is another way of writing, that is in the form of set of tuples. So written in the form of relations here and written in the form of set of tuples here. Okay. So that was an example for natural join. I hope you understood. Thank you.